All right. So let's see. Greetings, YouTube. Beautiful mind here. Thank you. Thank you for that. Let me see. Let this student in. Let's see. So no major announcements. We're just kind of making our way through the material. If you have a question about anything, feel free to type it in the chat or unmute yourself. Otherwise, we're gonna kind of keep moving where we left off. So we're in week 7. We have a total of about 12 weeks. It'll be over quick. Oh, so that means we're gonna have exam 2 is gonna be coming up. If we're going over, it's basically exam 2. You can anticipate it being from whatever we didn't do in exam 1. You know, I think it's just chapter 3 is gonna be exam 2. It should just be just chapter 3. Okay, and you can expect that towards the end of March, that fourth week of March. But yeah, so I think I did post a lecture for today already. It should be over section 3.5. So I'm just gonna hop into the homework assignments. So yeah, again, if you have questions, feel free to type it in the chat. We're just gonna kind of make our way through the homework. Okay, so we're moving into section 3.5, and I'd like to start on a question from 3.5. These first few questions are review from previous chapters and some things from college algebra. So I'm gonna go to section 3.5. It's 3.3. Okay. All right, let's give this one a go. So this is from 3.5. We're asked to maximize this function where x and y are positive numbers such that x plus 8y squared equals 6. Okay, this is fun. So maximization, that's basically what we're gonna be doing is looking at the first derivative. Ooh, I hope my pen is good. I hadn't even thought about trying to charge that thing. We're gonna find out. So let me take some notes. I think I'm gonna go ahead and suppress this. Let's go paper. Let's get some graph paper going. Now is not the time. Later. Let's see. I think we left off here. Okay. Hopefully the music's not too loud. Come on, I need you to chill. Close that out too. Put this back here. Cool. We're looking good. Okay. Let's see how this writes. That feels pretty good. Okay. So this is what? Week 7. Let me do my header. This is week 7. This is day 13. This is section 3.5, optimization. Business, I'm gonna say business, econ, and general applications. Okay. Applications. All right. Let's see, this is question number 6 from the homework. This comes from section 3.5, question number 9 from the back of that section. We're asked to maximize. We have this function q equal to x times y, where x and y are positive, x and y, I'm gonna just say is strictly greater than 0. And we're also given that x plus 8y squared equals 6. Okay. We're gonna hop over to the tablet. All right. So we want to maximize the function q. Let me think about it. Do we want the first derivative? Why does this feel? So let's get q in terms of one of the variables. Let's get q in terms of x, all right? Let's solve for, actually, it looks like it might be a little bit easier to solve. I was gonna solve for y and get y in terms of x, but I think I'm gonna get x in terms of y. That looks like that might be a little bit easier. Let's do that instead. So then x is gonna be equal to 6 minus 8y squared, right? Let's take this and let's get q in terms of one variable. So we're gonna get q in terms of y. So then q, yeah, I don't know what to do about the internet connection. Like, I got the best that they had. All right, we got a student coming in. Let me just take their attendance. This one looks good. And I'm gonna let him in. So yeah, so if we replace, well, we're gonna replace x with the function that we just found. So then q is gonna be equal to 6 minus 8y squared times y, right? So now we have q in terms of y. So we're gonna find basically dq by dy. All right, just basically q prime. So dq in with respect to y, basically let's distribute here. Let's go ahead and distribute this y. I think that'll make it a lot easier. So what we're going to be finding is d by dy, and we're going to have 6y minus 8y cubed. And then if we take that derivative, I guess I'll come here. That's going to be 6 minus 24y squared, right? So that's dq by dy. Okay, so that's the derivative of q with respect to y. So now if we're looking at the derivative, the maximum is going to occur at, so we need to find the max, right? So we need to, the max is going to occur when this last function is either 0 or undefined. Since it's a polynomial, it won't ever be undefined, but it can be 0. So we're going to set it to 0 and solve. So then we're going to have 6 minus 24y squared. We're setting it equal to 0. Now if we solve for y, we can add the 24y squared to both sides. We'll get 24y squared equals 6, okay? We can divide both sides by 24, so then y squared equals 1 over 4. Take the square root, so then y equals, normally it would be plus or minus 1/2, but I think it said that both x and y are positive numbers, so it has to be the positive 1/2. So then if we have y, we can go back and solve for x. Let me get a copy of this guy right here. Copy. Paste. And let me give myself a little bit of space. I'm gonna just move this over. Generate some space, okay? So we just solved for y, so let's take that and find x. So then when y is a half, then x should be 1/2 squared. What is that, 1 over 4? 6 minus 2. So then x should be 4, okay? So when x is 4 and y is 1/2, that should max. Oh wait, we need to, let's verify that y is indeed a max, right? So, I mean, that should be it, but we still should verify. So like say this was y, say, here's the 1/2. We need to see how the original function q, let me see. Yeah, how it behaves when we plug in that 1/2. I think, let me see. Let's look at q prime. So I think when we plug the 1/2 in for y in the q prime, that gives us a 0. So then something less than 1/2, we can choose like when y is 0. If we plug in 0 into q prime, right here, we're going to get a positive result. We kind of want that to be negative. Let me see something. I feel like I'm missing something. 0. The first derivative should be, oh, that's what we want. Because if we want it to be a max, we want it to be increasing on the left and decreasing on the right. So positive is correct, right? So if we chose a number less than 1/2, and we got a positive, for q prime, we got a positive result over here. So that means the original function is increasing, which is what we want. Let's choose something larger than 1/2, like 1. If we plug in 1 here, notice we'll get a negative result. So if we plug in 1, the first derivative is negative. That means the original function is decreasing. So then that confirms that the 1/2 is going to be our local max. And then we found the corresponding x. So it should be 4, 1/2. I think that's all the information that we need. So I'm going to say 4, 1/2. Let me let the student in. I thought I had turned on my notifications, but I'm not hearing anything. That's okay. All right, let's check this result and see if it works. It should work though. I don't see why it wouldn't. And let's do like this, like this, like this. let's hop here. Okay. Type an expression using y. Write the objective function in terms of y. Yep, that's exactly what we did. We found q in terms of y. Let's use this line. So we have, I'm going to say 6y minus 8y cubed. Okay. The interval of interest of the objective function. So if it's positive, so y has to be positive, so 0 to infinity in parentheses, 0, it might, let's see how this goes, okay, because y has to be positive. The maximum value of q, okay, so q is going to give us a value of, if we plug in that x and that y, I guess when what y is a half, what's the q? Ugh, come on, the iPad. Just keep that version. Let's see. A half squared is a fourth. 8 divided by 4 is 2. 6 minus 2 is 4. Half of 4 is 2. So then q has a value of 2. Oh, that was it? Okay, I feel like there should be questions. Let's try a couple more and hopefully something will sink in. Okay, I'm just gonna go into the next question. Okay, let's give this one a go. It says a lifeguard needs to rope off a rectangular swimming area in front of Long Beach using 2,200 yards of rope and floats. What dimensions of the rectangle will maximize the area? What is the maximum area? Note that the shoreline is one side of the rectangle. Rope off a rectangular swimming area in front of the beach. Okay. So let's hop over to the tablet and I'm gonna reread that. So right now, some people, I think my YouTube people will be able to see my iPad and you probably still see this text. So this is question number 7, because I would like you all to be able to see my text while I work through this one. So we have a beach, right? Let's hop over here like this. So we have a beach. Let me see. Life's a beach. Then you die. Okay. So like here's the sand, right? And then let's do like this. Over here is like the water. This is our water over this way. Do I like that? I could. No, I don't like that. So let's do like this. Boop. I'm gonna go like that. I'm gonna go here. I want this to be filled with this, and then I think I'm gonna just get rid of that. It's gonna be a little bit crude, but it is what it is. Like this. We're gonna make this be a beach. Nope, undo. Just trying to draw a picture of what's going on here. Style, fill with this one, and let's go style, stroke is like here. That's better. Okay. And then let's do, I'm just totally doing too much. Let's do something like this. Nope, undo. Nope, undo. And let's go here. I don't want it to be a hard white. It might have to be a hard one. That's not behaving the way I want it to, but that's okay. And we're gonna do this real quick. I'm just having just a little bit of fun. Okay, this is the beach, all right? And one other thing, let's just get some sand here. Okay. All right. So now the lifeguard. What's the lifeguard doing? Right? He's roping off a section of the water, but part of it he doesn't rope off because it's the shoreline, right? So he has a shape kind of like this. Let me see. Is it gonna let me? That's not gonna work. Let's try this again. I think I can do the following. So I gotta make an adjustment. Let me put that there. Let me do like this, partial Stop. Thank you. Let me cut this off, cut that off, and then I want to do the whole thing. And this is going to be our rope that the lifeguard is using to block off. Right? So that's the rope that the lifeguard is using to block off a swimming area. All right, let me hop back over and read some more. So a lifeguard needs to rope off a rectangular swimming area in front of Long Beach using 22 yards of rope, right? So I'm gonna write that down as the perimeter is 2,200 yards of rope and floats. What dimensions of the rectangle will maximize the area? We want to maximize the area. Okay. Okay. Let's go like this. Let's make sure the people at home are on the tablet. I know we have a bad connection, so we're gonna do the best that we can. Okay. So this is kind of the scenario that's going on, right? One other thing. Let's go here. That's fine. Like this. Waves, right? This is all water. Right? The fun part about word problems is drawing a picture. So, you know, just try to find your relief wherever you can. You know, that stuff is important. Okay, this is waves. Okay. So we want to maximize the area, right? The basic shape that's going on here is a rectangle, right? So say we said that this was X yards, basically from here to here, all right? That means that over here is also X yards, okay, from here to here. And then if those two are the same, and then this would be Y yards, right, from here to here, okay? So now, we have two formulas going on here, two formulas at play. Let's start with the perimeter. Now, hopefully, you can see that perimeter is not a set in stone formula, it's a concept, right? What is perimeter? Perimeter is the distance around the outside. So all we want to do is add up the distance around the outside. Notice that we're missing a side, right? We're missing that top one because that's where the people come in and out. You don't want to rope that off. But the basic shape is a rectangle that we're working with. So the perimeter here is going to be, hopefully you have it by now, 2x. It should be 2x plus y, right? Because if we just add up the outside, this was going on. The basic formula for area of a rectangle is length times width. In this case, it's going to be x times y. And again, we'd like to maximize the area, right? I think we have some more information. So we also have that the perimeter is 2,200 yards of rope. Okay. So this is, at this point, now that we have this set up, it's a repeat of the previous. Where basically we're going to get area in terms of one variable, probably x, okay? And then we look at the first derivative, you know, let's kind of this information. Okay, so then we'll have 2x plus y equals 2,200, right? This one should be easy to solve for y, so then we'll get y equals negative 2x plus 2,200, okay? Now we're going to take this and plug this into our area formula. So again, we want to maximize the area. So that's going to be x times y, but y is negative 2x plus 2,200, okay? All right, so now we're ready. Let's go ahead and distribute here, okay? Let's distribute. So then we get to the area is going to be negative 2x squared. Now, some images should already be coming into your mind at this point, right? What can you notice off the rip, right? Notice that the highest exponent is 2, so that's usually a parabola. Notice the leading coefficient is negative, right? So that means the parabola should be opening downward. So if we have a parabola opening downward, that's exactly what we need, right? That means we should have a maximum. So let's look at the derivative and let's find the coordinates of that max, right? So then if we look at a prime, that's going to be negative 4x plus 2,200. Again, this one's not going to be undefined, but it can be equal to 0. So we're going to set it equal to 0. Okay. Let's see. If we add and divide, let me see. X is going to be the 22 divided by 4. So that's going to be a 5. I think it's 550. Hey Siri, what's 2,200 divided by 4? 2,200
okay.
And then we should, let's confirm that x is a maximum. So say this is the positive x, here's the 550. We need to look at a prime. We need to see how. So if we plug 550 into the derivative, it should make it 0. Something less than 550 would be x for 0. Notice we get a positive result. Here, let's be a little bit consistent. So this would be 0. If we choose any number less than 550, we'll get and plug it into the derivative, we get a positive result. So that means the original should be increasing. A number larger than 550, say, I'm going to do 1,000, just because it seems easy to me. We get negative 4,000. Notice that the final result is going to be negative, so the original function should be decreasing. So then that implies that the 550 is a max. We could also look at the second derivative. If we looked at the second derivative, and when we plug in the 550, if we get a negative result, I mean, you can actually see it really quick. The second derivative is going to be what? Just negative 4. So no matter what x we choose, it's going to be negative. That means the original function is concave down across the entire domain. So that means we have a max. That confirms the 550. Okay. So we just want the dimensions. So when x is 550, then we need to go back and find the y. So 1100 even. So it looks like when x is 550, y needs to be 1100. Okay, hopefully that made sense. Okay, I am monitoring the chat, so if you have questions, feel free to either type it into the chat or unmute yourself for clarity. Okay. And hopefully you all were able to link up with like tutors, okay? And you've been working together. I don't want anybody to feel alone. I know we don't speak up, but you got to speak up. The sooner you can speak up, the better. If you're having trouble, and ask for help between either your classmates, and keep in mind you've already paid for tutors. It's included in tuition, so that's what they're just sitting there waiting for people to ask them questions. Let's try this on. Let's submit this result and answer the questions. Type an expression. Okay, so a of x. Using x as the variable, so we want the area in terms of x. That's where we got the negative 2x squared, negative 2x squared plus 2200x, 100x, right? Okay. The length of the shorter side is 550 yards. And the length of the longer side is 1100 yards. And then the maximum area, 1100 times 550. Hey Siri, what's 550 times 1100?
550
Ooh.
times 1,100 is 605,000.
Oh, even, okay. Square yards. So basically I said that 550 times 1100 yards squared. Okay. Area is always in the units for area are always squared. Man, people are just like, okay, let me see what we're looking like. 630, 715. Okay, we're looking pretty good. Okay, let's give this one a go. Like this kind of topic is, I think this might be my favorite in calculus. I mean, there's others. It's good stuff, and I've used it. Like I think one time I was doing a custom origami build, and I had these two pieces that naturally didn't fit. So I had like an octagon, and I needed a hexagon. So I did like a calculation. I drew up some geometry, used some calculus. It was actually kind of fun, and it actually worked. I did some measurements. I was like, okay, if I do it like this and fold it at this angle and put it together, it should fit, and it fit perfectly. I was like, oh my god, this is like magic. And I know that's what like programmers use this, scientists, doctors. I don't know that lawyers use this kind of stuff specifically, but they use logic. Construction, all the buildings, all the technology, we're surrounded by this kind of stuff. We just don't be aware of it, and like we don't think about it. But those that do think about it, that like actually use it to build stuff, I mean, they make bank. Like, any of us could get into those realms, especially like programming, any of that kind of stuff. I mean, 6 figures on up. Easy. Actuarism, doctors, lawyers, scientists, researchers, everybody. It's like we're surrounded by this. It's just on how you use it. Now, you can get into social economic stuff because, then I'm like, being black in America, I want to sing that Woe Is Me song. But honestly, if any of us just really push, we can honestly we can become whoever we want to be. My trouble is I can be indecisive and I don't really want to do stuff. I'm just doing it because I feel like I'm supposed to, but I don't really care. Like, I just, that's just kind of how I feel. But I like nice things, but I like my freedom. Like when I want to rest and do what I want to do, it's not a big deal. But when I'm on call, then that kind of that kind of rubs me some kind of way. That makes me feel some kind of way. You know what I mean? And I've been there for like a long time, like not really wanting to do anything. But my nature is I'm a jack of all trades and master of none. I can do any and everything that comes to my mind. I just don't, I don't really care. But anyway, it's fun. I'm trying to keep my spirits high as I can and just kind of keep it moving. Okay, enough of like me getting into that kind of stuff. So let's look at this one. We're gonna just keep moving forward. This is section 3.5, question 19. Okay, so another like building or construction. It says find the dimensions of an open rectangular box of maximum volume that can be made from a sheet of cardboard 25 by 14 inches by cutting congruent squares from the corners and folding the sides up. Find the volume. Okay, fun stuff. This is good stuff. Oh yeah. Okay. All right, so where are we? This is question number 8, right? I'm taking some notes. I think for my people at home, I'm gonna show my tablet and I'll kind of go back and forth for my Zoom audience. Okay, so this is question number 8. This goes to section 3.5, question 19. Find the dimensions of an open rectangular box. Okay, so let's show what we're doing. So we're starting with a flat sheet of cardboard, right? We're making a box. So our cardboard, I guess I need to add another color to this. Let me add this to favorites. Where is it? Can I not add another one? I probably gotta like suppress and bring it back, or where'd it go? Remove. Oh, there it is. Let me try it again. Okay, I'm not gonna worry about it. I know it's there. So we're starting with a rectangle. I think it's a rectangular piece of cardboard, right? They gave us the dimensions. So let me start with the rectangle. Okay, that looks decent. It's trying to lag on me. It's trying. And then I'm gonna do this. I want to fill it like this. And I'm gonna trace over that. Come on, undo. Let's try that again. I hope. Come on, there we go. And let's go here, style. I want that to be sharper, that's fine. And the fill is actually working too. We're gonna put you there, and you go there. That's good enough for me. And actually, let me do style. I want that to be thicker. Okay, that looks good. So we're starting with a piece of cardboard, right? And we're going to cut away a square. And let me look up the dimensions. So the dimensions of the cardboard is 25 inches by 14 inches, right? So this is 25 inches by 14 inches, right? So then we're going to cut away square corners. So I'm just going to draw a square. Okay, well it is a square. Let's do style. I want like this. That's good. And then let me do this real quick. Let's go here, partial. Yep, that looks good. We can do like that and like that. And honestly, try that one more time. Okay, that's good enough. Let me see. Hole. Like this. There we go. Let's copy it's one square that we're cutting away. This can go like here. Let's paste. Okay. That looks proper. And then paste. And I think this needs to go this way. Just trying to have a little bit of fun. That looks good. That is about right. Okay, so we're cutting away those corners, right? And we're gonna fold it up. All right, so when we fold it, we're gonna get the following image. So we can do something like this, like this. Let me not spend so much time. Let's copy this, go away. Let's paste. More simple, I think, would be kind of doing like this. Let's copy that. And let's paste. So we have this open top cardboard box. And just to bring it on home, I'm going to do the following. So we can't see, like, honestly, let's undo that. Like, that cut is there. This cut is there. This cut is there, and this cut. Okay, let's try this one more time. Okay, so then, let's see. This is gone, that's gone, that's gone. That's essentially what's going on here. All right, I'm trying to be too nitpicky. But anyway, this is the idea. See, now I'm totally just having fun. Let me just do this real quick. It shouldn't take that long to go from here to here to here. Okay, that'll work. Let me see if I can make these thicker. Style, maybe like that one. That's too thick. Right there, that looks good. Come on. Style. Okay, it's this one. Like, this app is kind of fun. Style, like this. You don't have to do all of this. I'm just, like I said, I'm just having some fun. And let me see if I can get one other little thing. Partial. So, like, now, in the spirit of what I'm doing with these images, so I saw something on YouTube where basically this guy, like, would take, like, live recordings. Oh, come on. What are you doing? Maybe if I do, like, this option. I don't understand why that's behaving that way. Okay. Where he would take, like, live video and then do, like, 2D sketches on top of it. And it's just, like, fantastic. I was like, oh, I got to figure that out. I totally got it. So what I'm doing is just, like, tracing over all the basic shapes. Like, this one is a triangle. You know, even though we see in 3D, we actually only see in 2D because it's like there's a 2D representation of everything we see because it's like a flattened image, right? So I'm just focusing on all the basic shapes. So there's so many different dimensional representations of all of our stuff. I gotta fix that last one though. Come on. It's supposed to be a polygon. Where's my polygon? Come on, undo. So let's do like this. We want 1, 2, 3, 4. Undo. Nope. Undo. I can't seem to get the polygon tool to work. Okay, one other thing I can do. What if I do? I'm gonna get it, hang on. That's my last try. Okay, that's what I needed to activate. It wasn't doing the power. I don't know how it wouldn't, why it wouldn't do the other one, but this will work. I'll make it work anyway. Okay, that's exactly what I needed. Boy, that was an adventure. Okay, anyway, we got, so this is the idea. I was just being a little bit artsy. Right, so let me highlight, hopefully, who is this? Okay, let me let this through here. I am king of procrastination. And it don't always work in my favor, but I'm good at it. Let me let this student in. Let me see the time. Okay, we're okay on time. So let me highlight some edges, right? So if we cut out these corners and fold up the flaps, we're gonna have this base, right? And let's do this color. We're gonna have this base, right? We have this blue. So the blue base on our folded up open top box is gonna be here. Let's undo. Let's actually undo that. Come on. And undo that. Let's try this again. So since we have this tool, I'm gonna go like this. Nope. Okay, let's undo. Let's do like this. Let's need a bar. Let's go style. I want it to be thicker. And actually I want to copy that, right? So this edge from the box is going to be this guy right here. Okay, and then if we were to do the same thing, let me just paste, but make that one purple. The purple edge is going to go from here to here. Let's copy that. That's going to show up here on ours, from here to here. So hopefully this is making sense. Okay. All right. So let me see. We're asked to maximize the volume. We want to maximize. We want to maximize the volume. Okay. So we cut some unknown length, right? Whatever we cut away from the dimensions of the squares that we cut away, that's what's going to change, right? So we're going to call this X, basically from here to here, right? So all the sides of the rectangle, of the squares that we cut away, all of those are X, right? So we can get an expression for the volume. So the height is going to be X, right? The unknown square, that's going to come from the dimensions of the square. The purple, if that whole right side is 14, then the purple is going to be what? 14 minus 2x. So the purple is going to be 14 minus 2x from here to here. Okay. And the blue is going to be 25 minus 2x. Because the whole bottom side is 25, but we got to take away the two x's from the two squares that we cut away, and that's going to go from here to here. Okay, that was fun. Okay, so then now volume of a rectangular prism. Again, we want to maximize our volume, and volume is essentially length times width times height. So it's dogs barking outside. My dog is trying to talk with them. They just out there being dogs. Let me see what else do we have. Okay, and I think we can get the volume in terms of X by itself, right? So we want to maximize our volume, the length, and here, let's do the length. The length is going to be style, it's going to be blue. The width can be our purple, and the height is black, right? So the length is going to be our 25 minus 2x, The width is going to be the 14 minus 2x, and the height is just going to be x, right? Let's expand this out so it's easier to take the derivative. Because again, we want to maximize, so we need to look at the first derivative. Okay, so I'm going to FOIL. If I have 14 quarters, if I had 12 quarters, that's what? $3? So 350. So 25 times 14 should be 350. Hey Siri, what's 25 times 14? Okay. Basically like you have 14 quarters, right? So if you had 12 quarters, that would be $3 plus 2 more is 350. Outer is minus 50x. Inner is what? Minus 28x. And last times last is going to be plus 4x squared. And don't forget about that extra x that we need to distribute. All right. If we keep going, I'm gonna go ahead and distribute the x as well. We're gonna get. I'm gonna put it in a descending power order. So we're gonna have 4x not squared but cubed. And again, what I'm doing is basically distributing this x and combining like terms. We're doing a few steps in one. Okay, that's gonna be what? Negative 78. So negative 78x squared and then plus 350x. Okay. Man, I don't know about you guys. I know the math might be what it is, but I definitely had fun making those images. Like, come on now, that looks good. You got to give it to me. That looks good. It's crisp. It's kind of it's not to scale, but I mean, you can actually do some really detailed stuff. This is just notability, but you can actually, like, depending on your patience and your attention to detail, you can make like really detailed stuff. It's fun. You just got to have patience and time. Okay, and so this is our volume that we want to maximize. We want to maximize this volume, right? And let's line this up a little bit better. Okay, you can go there. You can go there. Boom. All right. Let me just check some things. Hopefully, Ali Oxenfree. Okay, I'm just gonna let it be in. Okay. So now we got the volume in terms of one variable. So now we want to, if we want to maximize it, we want to look at the first derivative, and the max is going to occur if it exists, where the first derivative is either 0 or undefined. I probably should be identifying the domain, but you know, I think I'm just gonna let that be. Okay. It should be positive because we're dealing with distances, right? So then v prime, right? So if we take the derivative, we get 12x squared, 140, 156. So minus 156x. Yeah. And then plus 350. Okay, we want to set it to 0 and solve. Maybe we can factor out 12 from all of these. Hey Siri, what's 156 divided by 12? 13. Hey Siri, what's 350 divided by 12? The third. It's close. So it's even there. That's an 8. It's not divisible by 3. So we can divide it. It looks like we can factor out a 4 from everything. So we're basically going to set this as 0 and solve. If I factor out 4, we'll be left with 3x squared. Let me see if that's a 12. It's going to be what? 3 and 36 is 9. X, that looks right. 32 is 8. And 30. 4 doesn't go evenly? Shyster. I think 4 doesn't go evenly. 35 would be 32, 30, yeah. Hey Siri, what's 350 divided by 4? 350 divided by 4 is 87.5. So it looks like instead of 4, we're going to factor out 2 from everything. All right, so it looks like we can factor out 2. If we factor out 2, that makes this a 6. 14 would be what? 7, 78, and let me see, there's a 1, 15 would be 7, 10 is 5. Okay. Okay, I'm going to do it the way that I've usually. Now you can use things like the quadratic formula, you can use calculators, you can look at graphs. I'm going to factor this, assume that I could find whole numbers. And so what I'm going to do is look at all the factors. It might take me a little while, but between 6 and 175, right? Let's see. 6 times, let me see, how many quarters is that? That's what? 4 and 3 is 7. 36, 42. If I had 42 quarters, 40 quarters would be $10, $10.50. Hey Siri, what's 6 times 175?
6 times
Boy,
175 is
that quarter thing is so much fun to use. Okay, so 1050, right? Okay, so I'm looking for two numbers that multiply to give me 1050 and add to give me negative 78. Now we got the 1050 from the 6 times 175. Now I know the 6 is at least 2 times 3. 175, you know you can do at least 5. What's the remainder? Hey Siri, what's 175 divided by 5? It's 35. So then it's 5 times 7, right? So I think that these all should multiply to the 1050. I'm just going to check it really quickly. Hey Siri, what's 2 times 3 times 5 times 5 times 7? Okay. So now, so I'm going to go through all the combos until I get to the line that adds up to 78, okay? All right, so then let me see, we got 1 and 1050, but those are not the two numbers we're looking for. Maybe we can do 2. Now notice, if we use this 2, what's left over? We got 25 times 21. 20 quarters will be what? $5, so 525. That sounds right. Okay, let's keep going. We can do 3. That's going to be 25 times 14. If we had, what, 14 quarters, 12 would be 3, so 350. Hey Siri, what's 3 times 350? Okay. Notice we can't do 4 because we only have 1, 2, but we can do 5. All right, we can do 5. So if we do 5, what's left over? If we use a 5, 6 times 5 is 30, times 7 is 210. Okay. Notice how quickly these numbers are coming down. We started at over 1,000, now we're approaching less than 200. We can do 6. Okay, if we use the 6, 25 times 7, if you have 7 quarters, 4 is $1, so 175. Okay, but those are not the two numbers. We can do 7, because 7 is in our list. If we use the 7, 25 times 6, if you have 6 quarters, what's that, $1.50? Okay, we're almost there. We can't do 8, we can't do 9, we can do 10. What is that going to be, 105? So 10 and 105, but that adds up to 115. I'm going to move back up to the top. Let me see. We can't do 11, we can't do 12, we can't do 13, we can do 14. 14 is 7 and 2. So if we use the 7 and we use the 2, 25 times 3 is 75. What do those add up to? What are we looking for? We're looking for the line that adds up to 78. We're almost there. We can do 15 because we have a 15 right there. 35 times 2 is 70. So 15, 70, 89. Okay, so we're almost there. Let's keep going. 15. We can't do 16, 17, 18, 19, 20, 21. We can do 21. 21 is that with this. So 21 and 50. 21 and 50. That adds up to 71. Oh, did we miss something? That was 85. Maybe that 78 isn't right. Let me think about it. Times 2, yeah. Maybe it doesn't have integer exponents. I mean integer. Hey Siri, what's 6 times 175?
6 times 175 is 1,050.
Let me back up. 14. So if I look at the 14, if these two are gone, 25 times 3 is 75. That's not going to work. If we do 15, which are these two, 35 times 2 is 70. That adds up to 85, so that doesn't work. 21 would be this, and this, 50. That adds up to 71, and we're below a number. Nothing else is going to work. So what that means is that we can't get integer exponents. You know what? So at this stage, I would just do quadratic formula. And we probably won't get integer, we won't get whole numbers. Okay, so quadratic formula, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks. It was all over by 2 a.m. Okay, so then this is going to be x equals 78 plus or minus, and we could have did this on the rip. It's going to be 78 squared times 6 times 175 over 12. 6 times 4 is 24. Hey Siri, what's 78 times 78 minus 4 times 6 times 175? 1884. Oh, well, I guess it shouldn't be a perfect square. Let me see something, how they want the answer. Hopefully they want a decimal. Round to the nearest hundredth as needed. Okay, so we're just gonna find whatever that number is. Let's keep going. Square root plus or minus 78 over 12. Hey Siri, what's the square root of 1884?
The square root of 1,484 is approximately 43.4051.
4051. Okay, so it's approximately 43.4051 over 12. Okay. Now I'm trying to think, why would it be one over the other if we subtract the 43? Oh, so these are candidates for our max, right? All of that, you know, we were trying to solve the quadratic, set it to 0. We get 2 results. We need to see which one is going to behave like a max, right? So let's get those approximate numbers. Let's get those approximations. So let's go like this. We're almost there. Don't fret. So here's the positive x. Let's see. Hey Siri, minus 43.4051 close parentheses divided by 12.
78 minus 43.4051 divided by 12 is about 2.829.
Okay, that's an approximation. Let me see if I can just set a minus. I want to change that minus to a plus. Yeah.
The answer is
10.
10.117.
Okay. So these are our candidates, right? So what we're saying here is that when we plug these into V prime, when we plug, and let me move it down here. When we plug these into V prime, they should be zeros. So we want to see how the original function behaves on either side of these guys. So into the derivative, they should be 0. So if we choose a number less than 2, like say if we plug 0 into the derivative, right there, if we plug in 0, we get a positive result, right? So the derivative is positive, so we're saying the original function to the left of this should be increasing. A number between 2 and 10, I'm gonna do, let's do 5. So if x were 5 into the derivative, hopefully we get a negative. So if we plug in 5, hey Siri, what's 12 times 5 times 5 minus 160? Dang it. Cancel.
12 times 5 times 5 minus 60 is 200.
All right, let's try this again. Hey Siri, what's 12 times 5 times 5 minus 156 times 5 plus 350?
12 times 5 times 5
Okay.
minus 156 times 5 plus 350 is negative 130.
We got a negative result, which implies that the original function should be decreasing. That's what we wanted. Okay, let's just go choose something larger than 10. Let's choose like maybe 12. All right, we're gonna repeat that process in the derivative. Let's see. Hey Siri, what's 12 times 12 times 12 minus 156 times 12 plus 350?
12
it should be positive, and it is. Okay. So now what that means is that the 2.8829, that's going to be our max. This is going to be our min, but we want to maximize the volume. So the max should occur when x is 2.8829, and then we find the corresponding y. So let me get a copy here of this guy. I want to copy the volume function. Let's copy. And I'm going to paste it right here. Okay. So then now we want to plug that number in. I probably should use my calculator, but I'm going to try Siri once, right? So we're saying the maximum volume, if we plug in 2.8829, the output should be, okay, let's give this a go. Hey Siri, what's 4 times 2.8829 times 2.8829 times 2.8829 minus 78 times 2.8829 times 2.8829 plus 350 times 2.8829. I'm not going to do that again. I'm going to trust it. I could use my calculator. We got 456.5886. 5886. She's still going. I guess if I had the energy and focus to do that, she said I can match you. Okay, so when x is about 3, the max volume is about 457, whatever the units are cubed, okay? That was an adventure. We're gonna try that in Pearson. Let me just do like this, style, like this. Let me see my time. All right, I think I'm gonna make this the last one. So let's hop back over to Pearson. Let's see how do we do. Okay, and you don't have to do it the way that I'm doing it. I'm just showing you that it's possible. The dimensions of maximum volume, round to the nearest 100, use a comma to separate answers as needed. Dimensions. So, okay. What do we want? Length times. Find the dimensions of an open rectangular box of maximum volume that can be made. Okay. So we need to find those numbers. So we solve for x. We got x to be, and we need that line. Let me get a copy of this because we got to do a little bit of number crunching. So we want this stuff. Let's copy. Let's paste. And we want the dimensions. Okay. To the nearest 100, use a comma to separate answers as needed. The dimensions of a max. Dimensions. Trying to type this in. Nearest hundreds, 10th, 100, so 2 decimal places. Okay, so one of them should be, I'm a little bit leery about this, 2.88, comma, so I'm gonna say comma. Okay. Hey Siri, what's 25 minus 2 times 2.88?
25 minus 2 times 2.88 is 19.24.
Hey Siri, what's 14 minus 2 times 2.88?
14 minus 2 times 2.88 is 8.24.
Okay. And these are going to be inches cubed, cubic inches. Okay, we're going to cross our fingers. That's a lot of work. Let's see. I'm pretty sure it's our rounding that's off because I think everything else is fine. I'm going to view an example and I want to just see how they put their final answer. Because I know our logic was fine, like we didn't do anything wrong there. Let's keep going. Let's see if we can find it. I think we got all of that. We're going to keep going. We did all that. That looks good. Discard this value since the box is negative and the dimensions box cannot be negative. Is that the one that we used? That's probably why. We probably used the wrong X. No. But that wasn't a max either. Round to the nearest 100. That was our max. Whoa. Okay, discard that one because the side of the box that is negative in the dimension. Let me see. If we did the 2.88, let me check something real quick. No, we plugged that in already, and we didn't get a negative anywhere. Let me keep going. It might be around, and the second derivative is negative. Should be concave down. Oh, okay. So they're saying discard the value of 7.75. Yeah, we're good. Yeah, I think we're okay there. Tenths, hundredth. The volume. Okay, maybe. Okay, you know what? It might be our units. The dimensions. Let's do just inches instead of inches cubed. Oh. Oh man, that's why I used Pearson, because of the question how it was just the units. So that our numbers were actually, I was like, no, I'm confident in these numbers. I didn't feel like wavy or anything. I was doing inches cubed because anyway, the units for each one of those are inches, and then when you actually list the volume, it should be in cubic inches. So the max volume that we got, and it said nearest 100, so that's 2 decimal places. So we're gonna do 59, 456.59. That was fun, man. So I was gonna feel some way if those numbers were off. I was totally gonna feel some way. It should be inches cubed, and we are good. That was fun, and that was right on time. Let me check the chat. I don't think we've had any questions. So hopefully you guys were okay with that. But you saw what it took. Like I got flexible. Like I was going. I tried to do it by hand. We didn't get any whole numbers, so I was like, okay, well let me just use the quadratic formula. It was a flow, right? I mean, it was a little intense, but we did some together, okay? Okay. So hopefully you can take advantage of that. I'll be loading a lecture for the next section shortly. I usually try to have those up before the start of class, and we're entering the home stretch. The furthest we're gonna go is the end of chapter 4. We might truncate the last sections of chapters 3 and 4, something like that. But just essentially all of chapter 3, all of chapter 4. And in preparation for basically chapters 1 through 4, from beginning to end, okay? So we can anticipate exam 2 over chapter 3 at the end of March. And then the third and final exam will be the final exam, and that's gonna be from the beginning to the end over 1 through 4. Basically everything that we've talked about, but we should make it to just about the end of chapter 4, okay? So again, I'm not seeing anything in the chat, so I'm assuming you guys are okay. Let me hop over here really quickly. Not like that. Okay, and on that note, we're gonna end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace, guys.